Okay, so now we're going to continue on with hypothesis testing and confidence interval, but now we're going to be looking at comparing two samples. Well, the first thing we need to do is consider the differences between these samples. So if I'm looking at a dependent versus independent, dependent versus independent samples. Two samples are dependent if the members of one are paired up to the members of the other. For example, if we're dealing with the same person before and after. So for example, suppose we have two samples. The first sample is cholesterol level for a group of 20 patients. And then sample 2 is 6 months later after having been on cholesterol medicine for 6 months, their cholesterol levels. They're clearly paired up because it's the exact same person. Or two independent samples. If I randomly select 50 men and I randomly select 45 women and compare their BMIs, those are independent because each man is not being paired up with a particular woman. So two samples are dependent if members of one can be used to determine the members of the other sample. This is often when it's the same person. Or two independent samples if the sample values selected for one population are not related or somehow paired or matched with the sample values from the other population. The first type we're going to look at is inferences comparing two proportions. Now we have to have the proportions from the two samples be independent of each other. And for each sample, the number of successes and the number of failures is both more than 5, or that's to use the normal approximation for this test, which is the way your book does it. Now in Minitab, we're going to see that one of the options we have is to find the exact values. And I think it's better to find the exact values. So when we're doing Minitab, we do the exact values. On the test, you're going to be using exact values, but if you want to match the answer in the back of the book, you're going to have to use the normal approximation when you're comparing two proportions. This is very similar to what we did when we compared one proportion to a given value. We're still going to make a null and alternative hypotheses. The null will include equal. In these two sample tests, it is conventional for the null hypothesis to be parameter 1 is the same as parameter 2. There is no difference between the two parameters. The two proportions are the same, the two means are the same, the two standard deviations are the same. Or you can do it like we did before, and you can use equal to, not less than or equal to, or greater than or equal to. But the standard is usually just to say the null hypothesis is that the P1 equals P2, mu1 equals mu2, or standard deviation 1 equals standard deviation 2. And the alternative is the same as before. Either they're not equal to, there is a difference, or one is greater or one is less than the other. We're going to use Minitab to find the p-values. And when we do hypothesis tests, we're going to use the pooled estimate. When we use confidence intervals, we do not use the pooled estimate. I'll show you on Minitab during the lecture, the Minitab lecture, where you find that under options. And then we make a decision based on comparing alpha to the p-value, just like we did before. If p is less than or equal to the significance level alpha, then we reject the null hypothesis. If p-value is greater than the significance level alpha, then we do not reject the null hypothesis. So to use Minitab, we go to stat, then a box opens up, basic stat, and then you'll see where we had all the one sample tests. Below that is the two sample p-test. You're going to enter in the appropriate data. You select the pooled estimate if doing a hypothesis test, and you do not select the pooled if doing a confidence interval. And then under options, this is under options also, and you select the appropriate alternative hypothesis. So the confidence interval estimate, if the decision for a confidence interval, if there is no difference between P1 and P2, then the difference is 0. If you do 5 minus 5, the difference is 0. Same minus same number, the difference would be 0. So if the confidence interval does not contain 0, then we can say they are statistically significantly different. Otherwise, we cannot. Recall that in confidence intervals, you do not use the pooled estimate for confidence intervals. You're going to see this in greater detail where you find under options, use the pooled or calculate the estimate separately under options, and I'll show it to you in greater detail under the Minitab lecture for Lab 9. Here's an example. In this example, we're going to compare the proportion of these two medical techniques. One is using surgery and one is using a splint. So we have 73 patients that we performed the surgery on, and of those, 67 of them had a positive outcome, and 83 people we splinted their fracture, and 60 of them had a positive outcome. We're going to test the hypothesis that the results are better with surgery than with wrist splinting. And remember, for a hypothesis test, we're going to use the pooled estimate, and the alternative is greater than. If you go to Minitab and you go to basic stat 2 sample P, you enter in these values, make sure you change the alternative to greater than, and you check the box for pooled estimate. You should get a test statistic of 3.12 and a p-value of 0.001. My conclusion, P is definitely less than the significance level, so we reject the null hypothesis. There is enough evidence at the 5% significance level to say the results for the surgical group is better than for the splint group. You'll see, I'll do a couple more examples like this for you in the Minitab lecture. So for a confidence interval, let's construct a 90% confidence interval. Since we're now doing the confidence interval, make sure that we go back and we do not use the pooled estimate that's under the options page on the Minitab. We need to change the alternative to not equal to. And then the 90% confidence interval was this. 0 is not in this interval, so again we get the same result. We reject the null hypothesis. So next we're going to look at comparing two means when we have two independent samples. The requirements are the two samples must be independent of each other. Both samples have to be simple random samples. And either both samples are bigger than 30 or both samples come from a population with normal distribution. Now we have three types. The first one, if sigma, the population standard deviations are known, then that's one type. We use a normal distribution. Sometimes, if it can be assumed that the two standard deviations are equal to each other, even if we don't know what they are, but we can assume that they're equal to each other, then we're going to use a t-distribution with the pooled standard error. And otherwise, we're going to use the t-distribution for an approximation. On Minitab, there is a place to check the box, say assume equal variances or standard deviations, or do not. So you only check the box to use the pooled or to assume equal variances if you know for a fact that they are equal to each other. Either you're told they're equal to each other or you've tested them to see that they're equal to each other. Now, number one is very rare and it's not even dealt with Minitab, and so I'm going to move on from that. It is in your book so you can read about it, but it's not going to be on any Minitab labs, any homeworks, or any exams. To use Minitab, we go to Stat, Basic Stat, 2 sample T is down a little ways from the 1 sample T. You're going to enter in the appropriate data. If the two population variances are known to be equal, then you check the appropriate box. Otherwise, you leave it unchecked. And then in the options, you select the appropriate alternative hypothesis. So this is an example from your book. We're going to look at problem 8.3.9. We have two groups of patients, and we're comparing their brain volumes between a control group and a group of obsessive-compulsive patients. In each case, we took 10 patients. The average brain volume for the control group is 0.45 with a standard deviation of 0.08. And for the obsessive-compulsive patients, the sample mean was 0.34 and the standard deviation was 0.08. We are going to do a 99% confidence interval. to see if there's a difference, and we're also going to do a hypothesis test to see if they're different. So I go to Minitab and I go to Stat, Basic Stat, to Sample T. When I enter that information into Minitab, I should get a 99% confidence interval of this. Why don't you stop and check this out to make sure that you get these same numbers? If not, go back and try to figure out what you've done wrong. In this case, 0 is not in the confidence interval, so I reject the null hypothesis. The null hypothesis was, for the test, was that there was no difference, and the alternative is that there is a difference between the two means. When I go back and do a test, a hypothesis test, I get a test statistic of t equal to 3.07 and a p-value of 0.007. If I use a significance level of 0.01, again, p is less than the significance level, so my decision is to reject the null hypothesis. There is a difference in brain volume between these two groups. And I'm going to do another example in the Minitab lecture for you. The next one is we're going to look at when we have two matched pairs. In this case, the requirements are the sample data has to come from two matched pairs. They have to be simple random samples, and either both sample sizes are bigger than 30 or both samples come from populations with a normal distribution. Note the hypotheses are based on mu sub d, the mean of the differences. If they are the same, then their difference is 0. So we're going to use Minitab, we enter the data into two different columns. Then we go to Stat, Basic Stat, Pair T. Under Options, you select the appropriate alternative hypothesis. 8.4.6, this example is going to be done in the Minitab lecture for Lab 9, so you'll see that example there. Now, the last thing we're going to look at in this chapter is comparing two variations, either comparing two standard deviations or two variances. In this case, the two populations are independent of each other, and both populations need to be normally distributed no matter what the sample size. And it uses an F distribution. Now, the F distribution is similar to this chi-square distribution that we saw when we did the one sample variance. It is not symmetric. It's skewed right like the chi-square, so all the values are positive. And the exact shape depends on two different degrees of freedom. Large values of F are evidence against the null hypothesis. To use Minitab, we're going to go to Stat, Basic Stat, to Variance. You enter in the appropriate data. Either you have the data entered into two separate columns, or you're given the sample variance, or you're given the sample standard deviation. You choose the one most appropriate to how your data was given. Then the options, you select the appropriate alternative hypothesis. We're going to go to, I'm going to show you example 8.6.1. And for the treatment group, we had 25 patients. Their mean was 98.6. The standard deviation was 0.78. We had a placebo group of 30 patients. Their X-bar, a sample mean, was 98.2, and the standard deviation was 0.52. When you enter this information into Minitab under Stat, Basic Stat, to Variance, sample standard deviation given, and you put in the appropriate alternative hypothesis, which is a not equal to, you should get the test statistic of F equals 2.25, and the p-value being 0.039. Comparing this to a significance level of 0.05, we would reject the null hypothesis because p is less than or equal to the significance level. So there is a difference in the standard deviation between these two groups. That is the end of Chapter 8. Now, try some of the homework that's been assigned for this section. You can look at the next view, the lecture for the Minitab lab, and do the Minitab lab, and let me know if you have any questions.